All right, 8th graders, welcome to this explainer. Today, we are stepping into the role of mathematical choreographers to completely master coordinate plane transformations. I am super excited to guide you through this lesson where we'll uncover the secret language of movement on a grid and maybe even learn a little something about ourselves along the way.
Here's a quick look at our agenda for today. We'll start with the magic of transformations, figure out why they actually matter, break down the 3 basic moves, run through some real math examples, tackle a practice challenge, and finally, look at how education connects to morality and peace.
Okay, let's kick things off with Section 1, the magic of transformations.
So what are we talking about here? The absolutely crucial thing to remember is that transformations change a shape's location, but never ever its actual size or form. Think about sliding your textbook across your desk, hopefully to open it, right, not just to push it away. The book moved to a completely new coordinate, but it didn't suddenly shrink or morph into a different book. And that is exactly what we're doing on the math grid. We're taking a shape and we're just moving it to a new neighborhood. The whole shebang stays intact.
Now, it's really interesting how the source material links this mathematical concept to a deeper spiritual principle. The HeroesmartAcademy curriculum actually pairs this geometry lesson directly with this verse from Romans. It shows us that, hey, just as a point on a grid can be transformed to a brand new specific position, our minds and actions can literally be transformed for the better too, shifting right away from negative patterns.
Moving right along to Section 2, why transformations actually matter. Because you're probably wondering why you even need to learn this.
Well, you know those incredibly smooth video game animations you love? Yeah, that's literally the math of transformations working behind the scenes. When your favorite game character runs, jumps, or spins, the game's code is rapidly calculating translations, reflections, and rotations on a massive coordinate plane. So if you want to be a digital artist, an animator, or a game designer, this spatial reasoning is the exact foundation you need. It trains your brain to visualize symmetry and manipulate objects in space like a pro.
Let's get into the mechanics in Section 3, the 3 basic moves.
Okay, so you'll want to memorize these 3 steps because they are the only 3 moves you need to master this math. Step 1 is the translation. That's honestly just a fancy math word for a slide. You take your shape and slide it left, right, up, or down. Step 2 is the reflection. Think of looking right into a mirror. You're flipping the shape over a line, usually the x-axis or y-axis, to create a perfect mirror image. And step 3 is the rotation. This is just turning the shape around a specific point, kind of like spinning a wheel around its center hub. Sliding, flipping, turning. That's it.
All right, let's see these in action with Section 4, transformation math examples.
For our first example, let's look at a translation. Notice how sliding the point right adds to the x-axis, and sliding it up adds to the y-axis. Say we start at coordinates 3, 2. Moving to the right on a grid means we're heading in the positive direction on the x-axis, so 3 plus 4 gives us 7. Moving up means we're heading positive on the y-axis. 2 plus 1 gives us 3. Boom! Our new translated point sits perfectly at 7, 3.
Next up, our second example, a reflection. Check out how flipping across the y-axis completely reverses the sign of our x-coordinate. Think about the y-axis as a tall mirror standing straight up in the dead center of your grid. If our original point is on the right side at a positive 5, reflecting it means it has to jump to the exact opposite side of that mirror. So it lands on the left side at negative 5. But notice something? Its height, that negative 2 on the y-axis, doesn't change one bit.
Finally, let's look at a rotation. Here, a 90-degree clockwise turn swaps our numbers and changes the sign, which perfectly demonstrates the rule in action. We start at positive 2, positive 4. When we grab that point and physically spin it 1/4 turn to the right around the 0, 0 origin point, the x and y values totally trade places. The 4 comes first, the 2 goes to the back, but because it's spun down into the 4th quadrant, that 2 becomes a negative. Understanding these little number patterns is definitely the key to mastering this geometry.
Now it's your turn. Welcome to Section 5, your practice challenge.
Grab a pencil because it's time to put your spatial reasoning to the test. If you have 0.4, negative 1, what is the new coordinate if you translate it left 3 and down 2? Think carefully here about which direction means subtracting from the x and y axes. Remember, left means you're taking away from your x value, and down means you're taking away from your y value. So, start at 4, go left 3 spaces. Where are you? Jot that down. Okay, next challenge. Can you reflect point -3, 5 across the x-axis and rotate point 0, 6 90 degrees counterclockwise around the origin? These 2 problems test your ability to perform both a flip and a turn. For that reflection across the horizontal x-axis, ask yourself, does my left to right position change or just my up and down height? And for that 90-degree counterclockwise rotation, think about moving backwards against the clock. How exactly does that swap the 0 and the 6?
Last one for the challenge. How would you describe the transformation from point A at 1, 1 to point A prime at negative 1, 1? And can you graph an entire triangle reflected across the y-axis? Look super closely at how those numbers change from A to A prime to basically reverse engineer the move that just happened. The y value stayed firmly at positive 1, but the x value jumped from positive 1 over to negative 1. What kind of move causes that specific mirror effect? Once you figure that out, you're totally ready to graph a full triangle.
Let's wrap things up with Section 6, Education, Morality, and Peace.
As we explored earlier, the source material emphasizes a pretty profound idea. They ask, what's the point of being smart if we continue to make bad choices that hurt ourselves and others? The curriculum firmly intertwines biblical morality with education. You can know exactly how to rotate a point 90 degrees clockwise, but the idea here is that if you don't have a moral compass, that education isn't truly serving you. Knowledge is power for sure, but morality is the steering wheel.
They frame this mathematical knowledge within a much broader context, pointing out the peace of mind that comes from a spiritually focused mind. The creators of this material note that experiencing this peace isn't just some abstract promise. It's meant to be the actual experience of the people who engage deeply with their content. It's all about aligning your intellectual learning with your personal and moral growth.
So, here's a provocative question to leave you with. You've learned how to correctly transform points on a grid, but how will you use your education and morality to transform the world around you? You now possess the mathematical tools to choreograph movements across a grid without changing a shape's integrity. As you go forward, how will you move through life, maintaining your own moral integrity while making a real positive impact on your surroundings? I'll leave you to ponder that. Master the math, but more importantly, master your character. Until next time, keep learning and keep growing.